Okay, so, hello. We have a problem right here. So, let's just solve it up. I'll show you what we're going to have to do. So, for block A in the figure, it has mass m sub A equals 4.0, which is right there. And then I have my mass sub B, which is 2.0, which is right there. And then it says the coefficient of the kinetic friction between block B and the horizontal plane is mu sub k equals 0.5, so then it's right there. And then the inclined plane is frictionless and at an angle of 30 degrees. The pulley serves only to change the direction of the cord connecting the blocks, and the cord has negligible mass, so that's nothing we have to worry about. So we have to find A, the tension of the cord, and B, the magnitude of the acceleration of the blocks. So then, for the acceleration of the blocks, this is good because we only need to find one, because they're basically, it's set up on a pulley system. So as one has one acceleration, the other one's going to have the same one because they're both connected. So the first thing I have to do is I have to solve for F of F, friction. So then basically I have right here, and then I have my mu times the force of the normal force. So then I just put that into there, and I have 9.81. And basically that turned out to just be 9.81 newtons. So then that was my first thing. And then basically I went over to here, and I used Newton's second law. And then here's the law right there, and I put that in for each of my masses. And this is my mass 1, and this is my mass 2. So then for my mass 2, it's actually going to the left right here. So that means it would be tension minus the force F, because it's heading that way. And then mass 1 right here is actually, it's heading to the left, it's heading downward, so then it's going to be using gravity. So then it would be F of G sine theta minus the tension, so it's gravity equals ma. So then I have both my equations right here. So now if we go over to this one right here that I have, so now I have both my equations, and I just added them together, so you'll get the overall one. So then here it is right here, and basically what I wanted to do is I decided to do acceleration first. I wanted to find their acceleration together. So then I just tried to isolate acceleration, so I divided both the masses and put it over here. And then I simplified it, and there it is right there, and the answer was 1.635 meters per second. And the next thing that I had to do was I had to find the magnitude of, the tension of the cord. So then basically what I did was I just took the tension minus the friction, which I had over here, which is my other problem over there, and basically I plugged it back in for that, for the force, and then I got 13.08 newtons.